it's time for a long overdue update to the metal editor. There was a number of breaking changes in the end of March when they came out with Rev 39 of the emulator. And besides breaking changes, they also fixed the bug in JSR-FAR. And so that enabled me to do some things a little differently in the editor. And so there's been quite a few changes. And if you have been programming in the metal editor in Rev 38, and I realize I'm probably the only one, but if you have and you want to continue to program in Rev 41, there's going to be some patching to do. And here's how to do that. First thing you have to do is move your files from the previous versions of the emulator to the Rev 41 version of the emulator. And the ones that I wanted to continue working on are fast math, and I was using edit math as the program to edit fast math. So I moved both of those and the metadata for that as well. And then I also moved asteroid commander from Rev 38, and of course its associated data files and the metadata files for asteroid commander. So that's all now in Rev 41. The next thing you do is you're going to download the zip file that I'm going to upload to the downloads area of the Commander X16 website later today. And that zip file will contain this. All of these files here make up the metal editor. In the docs file there is edit.html. This uses the same CSS sheet as the Vera Programmer's Guide in the X16 documentation. And between this and the two appendices here, there's probably more documentation for the metal editor than there is for the Commander X16 itself. So you unzip it, you then copy all of this, Control C, and we'll go back into Rev 41 and paste it, and it'll overwrite a few files. That's fine. So now we've got all of this stuff in Rev 41. Now we'll open up Rev 41, and I'm going to go full screen for this. And I'm going to update asteroid commander. So load acom.prg, 8, 1, the same as before, but instead of running this program, we're going to load r41 patch.bin, 8, 1, and sys1942. This applies all the patches, fixing ROMB and RAMB. I'll come back to that in a moment, and we'll just give it the same file name. And it'll save all that. These messages won't appear in the future. And now we're back into the editor for Asteroid Commander. And there's a number of changes I have to make in Asteroid Commander. For instance, the mouse initialization and mouse get subroutines have to change, and there's some things that Vera has to, in my Vera initialization, that have to change. But if we go down here, we can see RAMB now. That's storing the accumulator in RAMB, and that's 8D0000 in that reverse column. In the Rev 38 version of the editor, this was 8D619F, and RAMB and ROMB have changed, but that patch in that one section of the patch updates every instance of RAMB and ROMB within your code to be the correct values. And if you've got other files, it only does the ones that are within memory. So if you've got other files that your main program loads, and those files have code that themselves refer to the RAM bank pointer or the ROM bank pointer, you have to load those files, and then you type cram, and that again applies that same patch to any instance of ROMB or RAMB, and then you just have to save that extra file, that file that you've loaded, whatever. Anyhow, that's how you update to the new file. So we're going to do the same thing. I'm just going to quit here, and if we list, we can see it's just the same program, but now when we run, it's back into the metal editor, and we're version 1.3 now. It was version 1.2 in Rev 38, but we're on Rev 41 and it's build 712. And we're back to being able to edit now in Rev 41. So that's great. I'm just going to close this and I'm going to open up another instance of the emulator and go full screen here. And we're going to do that same process for edit math. Okay, come on, and we're going to load the r41 patch.bin, 8, 1, and sys 1942. And there we go. Edit math.prg. Great. And I'm just going to quit. Okay, so this little chunk here is some test code that I did for testing out the 3D normalization function in FastMath. You can see here sta0 : ram_b. Now I didn't type it like that. When I typed it in, I typed it like this, sta000, because I did this in Rev 40, and this was build 701 of the editor that I programmed FastMath in. And so I had just programmed it like this, but new now in the metal editor is this implied label. What happens when it comes to a 0-page command like this is it looks at that location and says, is there a label there? And if so, it will display the implied label. And so that's one of the new features of this program. Let's just go ahead and show another feature of this program. I'm going to go brand 00. And you can see now that that branch shows up as being, reverse characters. And this also works on BBR, BBS, and all the other branch commands. If it's a 00, it'll show up in reverse characters. And it's quite apparent when it's the only ones in that column that show up in reverse characters is branch 0. And this will happen if you insert and it pushes the branch beyond 128 bytes. It'll just say nope, and it's a branch 0. And then when you're looking at your code, that'll pop out. Another thing is if you branch to a byte that's being deleted, that it'll just say branch 00. It nopes out of there, and thereafter your code will show up. When you see that, you'll see, oh, there's a branch 0. I have to pay attention to that. Now, you might want to do a branch 0 on purpose. That's a 3-cycle no-op, but at least it'll be brought to your attention every time you see this particular section of code that there's that. So let's see, what else? Let's go into FMLT, the fast multiplication function. Now, I haven't loaded the FastMath file into this bank yet. L file was the subroutine that I was executing to load that file into that bank. I would normally type exec L file back in R40 when I was first writing FastMath, but instead what we're going to do is we're just going to load it now directly into here. And there we go. Now FastMath is loaded into bank 1. And I know that fmult, the fast multiply, is used a few times, but let's just see how many times. I'm going to type used. This is a new function, and we can see now that it's been used 10 times, and it's all within bank 1 that it's been used. And we can go to any one of these and hit F1, and we can see there's the command where it's been used. And this is very useful for going backwards through a program. You can see how many times has CRO/ been used. Well, we can see it's been used 3 times. We'll go F1. Here's the very first instance of it, and it's here in the cross product subroutine. So let's see, that's used. What else have I got here? Let's go to C000. There are now 32 ROM banks as of Rev 39 instead of 8. So now when you go bank, you have to type a 2-character code. And if it's 20 or over, it'll just end it with 1F. So it'll always be within the value 00 to 1F. So let's go to bank 6. This is the care set bank. And if I go to F4, you can see the bit patterns for there's a number of character sets in here. Actually, a character set only requires 2 kilobytes in 1 bit per pixel mode. So yeah, you can copy this down into low RAM and make changes on it in mode 4 and then save that as a file, and later on load that file directly into Vera at 1F000 and have your own custom character set that looks better than the default one. And let's see, what else do I have on my list here? I believe that's all of it. So there you go. Let's see. I'm going to go into. Actually, I'm going to go into fast math here, and I'm going to make some changes while I'm at it right now. The F cosine table here it's got its own page of RAM, but right before that is the sine table, and B040 is 90 degrees into the sine table, and as you can see, it's identical to the last 192 bytes of the sine table are identical to the first 192 bytes of the cosine table. And I had it in its own page of RAM so I wouldn't be crossing pages when going in looking at an FCOS. But that's only one cycle difference at the expense of having an entire page dedicated to FCOS. So what I'm going to do here, I'm going to go to NOR2. Now NOR2 is a table that's used by the 2D normalization function, and the first 64 bytes of NOR2 are not used. If it turns out to be one of those values, it doubles everything and then tries again until it ends up with values in the 64 to 127 range. So we're not using these 64. What I can do is copy the last 64 bytes of the cosine table here into NOR2. And in fact, I don't even have to do 64. I can do 63 of them because the first byte to be copied is going to be a 00 anyway. So I'm just going to copy from B1C1, which is the start of the last 63 bytes in the cosine table, to BA01, and we're going to go 63 bytes. There they are. And now the first 64 bytes of NOR2 are identical to the last 64 bytes of the cosine table. Let's go to the cosine table. And so that's at B100 right now, but we want to move it to B040. So move FCOS to B040, and we only need to move the 1 byte because we just need to move the label. And you can see none of the data on the screen has changed except for the addresses. And now our final step here is to move NOR2 to B100 00. That's another change that I made to the program. 00 used to mean abort, but you can abort with backspace. So now 00 means 256 bytes. And so now those last 64 bytes of the cosine table are contiguous with the rest of the cosine table. And for the expense of one extra cycle for 1/4 of the references to the cosine table, we get a free page of RAM within this bank. And if I go to here, I've got 66 bytes free at bend, which is the end of code in this RAM. And right after that is the MIT license, 14 bytes, and then there's 6 more bytes free for jump table vectors. So I can add a couple of functions here now. I'm going to add a function, I think, to convert from fixed point 16.8 notation to this fractional notation. and back. And it'll be sort of a pseudo floating point, kind of a fractional notation. And that I think is going to make fast math a lot better. But because I've done all these changes, now I'm going to have to save, and I'm going to give it a different name, fastmath2.bin. And that just saves the bank. It doesn't save any metadata. So if I go to test, now I'm going to save this as editmath2.prg. And that takes a little longer because it saves the metadata files. And now I can go forward and continue editing in FastMath2 later on. So that's pretty much it for the changes to the editor and the new features. And have fun programming.